Good morning, guys. All right, so I'm just going to continue this video. It's going to be continuing on from our lesson on section 4.3 in the trigonometry unit for math 30-1, which is called trigonometric ratios. So we left off starting example 6, which we call the cast rule. Okay, so the idea behind the cast rule is that if I take a point that is in this quadrant number 1. Why is this being so finicky? And I draw a point over here, x comma y. So the idea here, when we look at a point like this, the x and the y coordinates can be positive or negative depending on which quadrant you're in, but the radius is always going to be a positive value. This is how we kind of define the radius of a circle. It's always going to be a positive value. So when we look at this one, and we look at cosine, sine, and tan, when we look at this, cosine is x over r, which is going to be like a positive value over a positive value. So therefore, it's going to be positive. Cosine is going to be positive. If we look at sine, it's also going to be a positive over a positive, which is positive. Tan is y over x, which again is positive over positive. So what we're trying to get at is that sine, cos, and tan are all going to be positive. So if I put an A in this quadrant, this is signaling that all sine, cos, and tan are positive in this quadrant. If I do the same thing for in quadrant 2, well, what you're going to see here is the x is now going to be a negative value because we're going to the left. So when we do cos, sine, tan in quadrant 2, well, cosine is going to be x over r, but x is negative and r is positive, so this is going to be a negative value. Sine is going to be a positive y divided by a positive r is positive. Tan is going to be a positive y divided by a negative x, which is going to be negative. So in quadrant 2, sine, so to put an S, is the only ratio that is positive. In quadrant 4, this x, y is going to be negative, x is going to be positive. So we have cosine theta, sine theta, tan theta. Cosine is going to be a positive x divided by a positive r is positive. Sine is going to be a negative y divided by a positive r, which is negative. Tan is going to be negative y over positive x, which is negative. In quadrant 4, so in other words, in cosine is the only way that we can, the only positive ratio in quadrant 4. In quadrant 3, x and y are both negative. So if I do sine theta, I get negative y over positive r is negative. Cosine negative x over positive r is negative. A tangent is positive because it's a negative over a negative. So it's going to give you a positive. So in other words, tan is going to be the one over here. So when we say the cast rule, it goes C-A-S-T, which spells the word cast. Okay. Now we use this to determine the signs, either positive or negative, of each trig ratio in each quadrant. Okay. Now, the trick you need to know is that the word cast begins on the bottom right. Okay. And we do this because the word cast is easier to remember than the word astke. So it's just this is how we do it. Okay, so cast, you start in the bottom right and you spell the word cast, and this is how we do this one. Okay, example 7. Determine the value of cosecant given that cosine is negative 5 over 6 and cotangent theta is less than 0. Okay, so when we do this question, we're going to start by using our cast rule. So So what this is telling us is that cosine is negative. Okay. Now the other thing over here, if they say cotangent is less than 0, which is cotangent negative, cotangent is the reciprocal of tan. Therefore, tan is negative as well. So if cosine is negative, well, cosine is positive in the C quadrant and it's positive in the A quadrant. And tangent is positive in the T quadrant. That means we must be in the S quadrant over here. Okay, so what we have here is we have cosine is negative 5 over 6. This is our x value. This is the r value. So r value is 6. Our x value is negative 5. And I'm just going to do a bit of Pythagoras. And I'm going to go 6 squared minus negative 5 squared, which is 36, minus 25, which is 11. Square root of 11 is, so normally it would be plus or minus root 11, but in this quadrant, sine, or my y value here, is going to be positive, so it has to be a positive square root of 11. Okay. Now, the question they're asking is for cosecant, and we need to know that cosecant is a reciprocal of sine, or r over y, which is going to equal to 6 over root 11 multiplied by root 11 over root 11 is 6 root 11 over 11, and this is our answer for cosecant for this question here. All right. Example 8. Determine all values to satisfy the following trig equations. Okay, so we're going to cover this in more detail in the next section as well. But so from 0 to 2 pi, we have sine theta equals negative root 3 over 2. Now, remembering from this, sine is the y coordinate on unit circle. Okay, so what we're going to do is we're going to look at a unit circle and say, well, where does sine equal negative root 3 over 2? Here and here. Okay, now the answer, we're looking for theta, which is an angle. So what we're looking for is the angle in radians, because it's from 0 to 2 pi. So it's going to be this angle and this angle over here. So therefore we have theta equals 4 pi over 3 and 5 pi over 3. Okay. For part B, sine theta equals 1/2. Similar, so now we want to find the y coordinate. Where does y equal 1/2? And it equals here and here. Okay, and we want to go and say, well, we're on from pi over 2 to negative pi over 2. So from 0 to pi over 2, it's going to be from here to here. That means I'm going to hit this angle of pi over 6. And this is actually going to be the only solution, because if I go from 0 to negative pi over 2, it's going to be from over here to here. Well, I hit a negative 1/2, but I don't hit a positive 1/2, because that's going to be way over here. So I can't get to this guy over here, given this domain here. Okay, so the only solution for this one is going to be theta equals pi over 6. Okay, tan theta equals 1. Okay, now what we know about tan theta is y over x. Now, if we get an answer of 1, what this means is that y and x have to be the same value. Okay, now looking at your unit circle, where does that happen? Well, it happens twice. It happens here, where at 45 degrees, because we're in degrees for this one, where x and y are both root 2 over 2, and it happens down here at 225 degrees as well. Both the x and the y values are both negative root 2 over 2 as well. So we just know that theta is going to equal 45 degrees and 225 degrees. So if you look over here, this is telling us that we're looking for an answer in degrees. Okay, so from 0 is less than theta, which is less than 306 degrees. That means give your answer in degrees. In example D here, we're giving an answer from 0 is less than or equal to theta, which is less than or equal to 2 pi. This means we're looking for an answer in radians. Okay. Now, what this means again is the x value is negative root 2 over 2. So looking at our unit circle, where does that happen? It happens here and here. Okay. So these two angles are going to be theta equals 3 pi over 4 and 5 pi over 4. So they're going to be those two solutions. All right, guys. So this is kind of a very basic intro to trig equations, and in the next section, 4.4, we're going to kind of get into these trig equations in a bit more detail as well. All right. I will see you in the next video.